Okay, yo, bro, this is the second part of it. So assume four children born in a family. What is the probability that all of them are girls, right? So four of them children are born in a family, right? So let's say mom and dad, right? And first they probably get a boy or they get a girl, right? So the first children are boy or girl. Second children, for let's say if they get a boy first, the second children either would be a boy or either be a girl, right? And uh, let's say if they got a girl first, it would be either boy, girl. And let's say the second was a boy, it would be boy, it would be girl. And by the way, it's all half, half, half. This is all half, like half. So don't worry about that, right? And let's say if this first one was a boy, second one was a girl, you can either be a boy, you can either be a girl. The third child, these are the third child. So I'm on the third child generation right now, right? So this would be either a boy or this would be a girl. This would either be a boy or this would be either a girl, right? So now the fourth generation, these are the chances they can get. Boy, girl, boy, girl, boy, girl. Oh, this is so bad. I'm so sorry, girl. But I'm pretty sure you'll get the point. Like I'm trying to like, girl, boy, girl, boy, girl. So there's, oh, I'm pretty sure this is 16 of them. Yeah, 16 of that. And yeah, so you get four, like you get, these are the possible outcomes you can get. So yeah, so so the question is asking if four children were born in a family, what is the probability that all of them are girls? So which ones are all girls? So let's find that. So it would be here. So the first child would be a girl, obviously. Second them would be a girl as well, because all of them are girls. Third would be a girl, and fourth right here would be a girl. So 1, 2, 3, and 4, right? So these four girls. So and it'll be, and how many branches are there? There'll be this right here is a whole branch. This would be a whole branch. So any four outcomes are one branch. If you want to count branches easily, it would be like this. You can just do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and this the 12th branch was all of them were girls. This was 13. This is 14, 15. So 16. So the 12th branch out of 16, right? So it would be 1/16. So the answer, that's the answer, 1/16. He also mentioned this too, if you want to know, like for basic knowledge. P, G, 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 G. This is a based off formula, so that would be equal 1/16, right? If you want to write it in the formula that I showed in the previous video, this formula right here, the PAB, you can put it like this: G4, so the fourth girl, G3, G2, G1, and then I'm pretty sure that's also 1/16. All of them are. By the way, the answer is 1/16, but these are just different places to put it. You can also put it like this intersection. So G4, G3, G2, G1 intersect, right? And that'll be 1/16 as well. And there's another one as well. He's like, these are optional, by the way. So yeah, so just letting you know for your knowledge. So you can do this as well. 1/2, 1/2. And also, if you multiply all that together, it would be 1/16. Because you know how, like I said before, every one of them was half, half, half. So yeah. So yeah, that's the first question. And the second question is, what is the possible probability of three girls and one boy? So, by the way, it doesn't show us it doesn't tell us the order of it. It just said three girls and one boy. It didn't say which one is boy, if boy came first, or the girl was born first. It didn't say that. It just says what is the probability of three girls and one boy. So if you go back to the tree that I made, the shitty ass tree, three girls and one boy, right? So let's say there's one girl right here, two girls right here, three girls, and then boy. That's one, right? One girl, two girls, two girls, and then boy, and it will add up to 4/16. So if you count them properly, it will be equal to 4/16. So 4 out of 16. So these are the possible. He also mentioned the possibilities. So either the girl was born first, the girl was born second, the girl was born third. It would be that. The boy will be last, and then or you can do this. Girl, girl, boy, girl, or girl, boy, girl, girl, or boy, girl, girl, girl. So these are the 4 possibility outcomes you can do. Yeah, this is another way of doing it without the branch tree. The branch tree is more easier because you can count it, like you can count it like just mentally. So it would be that 4 out of 16. And what if okay, now the third question is, what if the wait, did I forget anything? That order does not matter. Oh yeah, order does not matter. Oh boy. Oh wait, I actually forgot something. So he mentioned a few other things too. This one's a little complicated, but yeah, you get it. So the answer is 4 out of 16 in this. But we know in this question the order does not matter, right? Does not matter at all. And if you count towards like how much boys and girls there are, so in total there's 4 children, right? And there's 3 girls. So in class, I also asked this question. This would equal to. I'm pretty sure this would equal to 4 out of 16. I mean, no, my bad. I don't know what this will equal to, but he just wrote this. But well, like if you want to write it down in combination terms, we would just write it down like this. The reason why we don't consider the 1 boy is because look, 4 out of 3 can also equal to 4 combination 1. It's the same thing, right? And he wrote in other terminology terms if you want to know about it. So it would be success, girls will equal to P, right? And failure, which is 1 minus P, right? And yeah, so you can do this, look. Girls, the failure would be boys, I guess. Yeah, it would be boys. So you can either do it like this: P, girl, P. B would be 1 minus P because I said girl. Failure equals to boys, and girl will equal P. This doesn't matter about the order. Like you can do it in any order if you want to do it. So we follow this formula that he put out would be PK 1 minus P. N minus K, right? So if you want to put this in terminology, like in terms of the question, this would be 1 P would equal to 1/2 because you know the chances of getting girls if you look in the tree would be 1/2, right? 1/2. Put it like that as 3, like, and then 1 minus 1/2, that would equal to 4. 4 because 4 is the n because we have 4 kids in total, and k would be 3. The reason k would be 3 is just 3 is just equal to the number of girls. So k is equal to the number of girls. So yeah, you know how this is the combination terms would be n k. That's why. So yeah. Yeah, and that's it. He said like I also asked another question in class. I said like, don't you need a calculator to like figure this out? He's like, yo, it's fine as long as you just plug in like this. This is more than enough. Like as long as you understand the formula, that's it, right? So what if, okay, now let's go to the third question, right? So what if the first 3 were girls and the last one is boy, 4th child, right? So the last one is the boy. The boy is the 4th child. That's why I mentioned. So we would equal, like if you want to put it in terminology, would do this: 3 girl plus the 4th one was a boy, right? I'll just put B, yeah, and this if you can either like if you look at the tree, if the 3 of them is girls, so the first 3 will be girls. So girl, 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 and then the last one was a boy, right? So it would be boy, and there's only one outcome of that, so it would be 1/16 as well, right? So if you just multiply all of them like that together, this is a independent question, by the way. It's an independent type of question. All 3 of these are independent questions, right? And this would be 1/16 because there's only one possibility of that. So yeah, that's pretty much it for the second part.